So, so the session starts at 4:50, and it'll be in Kelvin downstairs. There'll be 4 talks, and the last talk is one of our distinguished paper award winners, and I'll talk about these papers in order so you can see them consecutively. But first, let me give you some background that, at least informally speaking, gradual typing is about the idea of being able to move between multiple reasoning disciplines. That's why I'm putting types in parentheses here, because it's not fundamentally about types, at least in my brain. A type in a program logic is the same kind of beast with a few different properties. So classic industrial example of this idea that people think of would be the connection between JavaScript and TypeScript. Another example that appears out in the wild is PHP and Hack as the typed. But as I'll come back to these examples later to talk about how the POPL community tends to treat some of these phenomena a bit differently than industry, and there's good reasons on both sides. But there's also this kind of point of view of just thinking in general about having composing components that have some notion of mismatch to them with respect to their reasoning principles. So over here, I was kind of describing this dial where you start with your PHP code, and then needs more cowbell or needs more types, and so you turn it up. You turn up the volume, but you might also find yourself in a situation where the type system that you have is not working with your reasoning principles, your kind of operational reasoning principles. So you might turn the types down and tell the type system to be quiet because you know what you're doing, possibly trust but verify. And here it's more that you want to even just be able to have things interact with one another. And these are not different concepts, but they play out differently in practice, where you might find yourself combining 2 pieces of code and then possibly performing migration, or doing some migration and then adding some more code from the outside. And so we'll see that both of these themes show up in the papers that arise here. So one of the key things that we care about here at POPL is about reasoning principles, and I think especially in the types community and also in program logics community, the idea of being able to reason modularly is really important. And you can see this even in the most basic type system, where you say, I want to say something about a program fragment, and how do I say something about a program fragment without having the entire program? And you do that by making a broader judgment which says that in an appropriate environment in which my code is being embedded, the code itself exhibits some behavior summarized here. And this just happens to be a simple type system, but most type systems and program logics could be described as variations on this theme. How do I talk about a small piece of code and think about and try and abstract away what's happening in the wild? And then in addition to modularity, you want to think about compositionality. And here I now have sort of 3 modules. And we talk about how do we given what I know about a module, and given what I know about a module, how do I perform composition? What are my composition principles? So I think both modularity and composition, they play together importantly, but they're not necessarily the same thing. And so to me, yeah, addition is just a sweet linking technology. But again, it's a variation on a theme. How do we think piece by piece rather than globally? And things get a little bit more complicated when you switch over to, say, something like gradual typing. And I'm not going to explain a lot about this, though I expect papers will some of the talks today will talk about it. But you now introduce this new idea of sort of, what does it mean when I have less or more precise specifications in a certain sense that leads to a relationship between your reasoning principles that ends up not being subtyping for reasons I just don't have time to explain, but ends up being things where there is a fundamental mismatch, and often that mismatch gets bridged by using runtime checking in situations where you can't do it. And then the question that arises is, how do I even have linking principles that will work so that addition can work when I say, oh, I don't really know what kind of thing I have, but I want to be able to create a module that behaves this way. And the short story to the trick is that you have to reinterpret to some extent what the entire judgment means in a way that is somehow compatible with your original static one, but allows you to have a bit more flexibility. And then you have to reason about what computationally happens when you run the code that's linked this way. And so you have this combination of your static principles change, and then your dynamic principles change in a way that is simpatico. Thanks. So the general strategy for the implementation of such languages is that you usually have a language which mixes together the 2 puzzle pieces somehow, or you can think of every individual operation in your language as a module, and then you have some sort of reasoning-directed translation strategy to another language that then performs instrumentation wherever you have impedance mismatch somehow. And you might have to have, because we have lots of different reasoning principles, you might have some sort of global monitoring as well in order to make sure that everything holds together and fulfill some reasoning principles. And then you have your monitored execution, and that's probably where the runtime monitoring happens in addition to the instrumentation in order to make sure that you get results that are compatible with what you're thinking. So, as I described, our desirable properties for these systems is you want reasoning principles. The conservative extension is basically saying if I have a dynamic language and a static language, if I paint my entire program one color, it should behave as if it was the one color language. So if I erase all my types from Hack, I should really behave like PHP, and vice versa. That if I have a totally static language, I really want it to satisfy on both ends. And then you want some notion of how can I move the dial. And there's some reasoning principles that are in the wild about how do I talk about the continuum between fully one discipline and fully another. So our first paper is about connecting verified code and what they'd call adversarial code in a context where you're working with input and output data. And the idea is ultimately you take some code that has verified security properties with respect to input and output, and then you compile it to a language that mixes in adversarial context where it can either be that your verified code is a library that's being called by unverified code, or you can have unverified library that's being used by verified code, and you have to have a shunt to perform the instrumentation, and then there's runtime monitoring as well to make sure that traces of I/O behave according to certain properties, and they were able to kind of get this to work. It's pretty cool. Then this paper is about program logics, where you have the idea of like a separation logic, which also allows you to have a bit of loosening things up as well. And then some of your verification happens in your program logic, but then instrumentation happens to your program that you run. And one of the things they discovered was that if you do this naively, your code runs way too slow. And so they use symbolic execution in order to remove some of the instrumentation, but earlier work on this tried to do that and ended up having soundness errors that you wouldn't have had if they didn't try to remove the checks. So they formalized their symbolic execution and their strategy, and ultimately show that their system removes checks and does it in a way that they can guarantee that that final results are sound. So you have that simpatico at the bottom of the diagram I showed you earlier. This paper is purely about going from being slow to being fast in a program that's already gradual. So they're not trying to migrate the language, but what they're instead trying to do is get the runtime to work faster by exploiting what type information they have. And they use this strategy called variational typing, which is basically this sort of, you could think of it as BDDs for programs, for typed programs, where you can overlay a bunch of programs into one thing, and you can perform type inference on the entire glom of them simultaneously, and then you can project out a program where some of your functions are more statically typed variations of others, and they can pick it in a way that they guarantee the calls will all be sound ultimately, and some of them will take the fast path and some of them will take the slow path. And the last paper, this is a really interesting one because it's gradual with respect to like, yeah, I'm programming in a typed language, but I'm working in an editor. And so most of the time your program's not well typed. And so they sort of treat this as a component model problem between code that isn't going to type check yet and code that's going to type. And what they do is they take a language which has a bidirectional type system, which is a way of designing a type system so that type information flows from the context and out from the results in ways that are really nice for reasoning locally about types. And then they basically like pour in steroids, which makes it so that you can type every state of well-formed but not necessarily well-typed editor states, such that some ill-typed parts are marked as independent parts, and then the typed parts are typed according to the normal strategy, and they can localize errors and overlay on top of that some constraint inference, primarily for the purpose of giving good IDE feedback to someone who's trying to figure out how do I get my program done. And they even exploit the order in which you write your code, so they have this edit calculus that they talk about being able to integrate this with so that your locality is actually relevant relative to how you wrote your code. And this was a paper that won one of the distinguished paper awards. So I think this is all really neat stuff, and there's a real common theme here, and I hope you enjoy. Thanks.